Okay, so welcome to video 4 for section 8.4. So let's recall that if we're given either y is equal to a times cosine of n theta, or y is equal to a times sine of n theta, then the amplitude is the absolute value of a, and that is the distance from x-axis, provided there's no vertical translation, and the period p is given by 2 pi over n. So hopefully we remember that. And let's note something about the amplitude. So the amplitude A is equal to the radius in polar form. Okay, so definition. So now general circles. We did circles in our previous video of the of the form r is equal to a number, but now we're going to do general circles in the polar plane. So a circle of diameter a in the polar plane, is given by number 1, r is equal to a times sine of theta, which is going to be an up or down circle. So what does that mean? How can a circle be up or down? And the center is going to be at 0, comma a over 2. Or it's given by r is equal to a cosine of theta, which is right or left. Once again, how can a circle have direction? I'll show you in a moment. And the center here will be at a over 2, comma 0. Okay, so for example, let's go ahead and plot the following. So example, plot the following in the polar plane. So plot the following in the polar plane. Okay, so number 1, let's say we're given that r is equal to 3 times sine of theta. Okay, so the diameter is 3, and the center, because this is sine, is going to be at 0, comma 3 over 2. Okay, so let's go ahead and plot this. And hopefully this will become clear what I mean by up, down. 1, 2, 3, 1, 2, 1, 2. Okay, so plotting this, my diameter is 3. And my center is at 0, comma 3 halves. Okay, so that means that my circle looks like so. It has a length, if you will, or a diameter of 3, a radius of 3 halves, and is up. Notice that this is up. So that's what I mean by up for sine. It's either along the y-axis, either up or down. Okay, so let's do another one. Number 2. Let's say we have radius is now 2 or negative 2 sine theta. How about that? Well, the diameter is negative 2. And how can a distance be negative? Well, that just means how I'm measuring from the pole. The center, once again, is going to be at 0, comma, diameter negative 2 over 2, which of course is 0, negative 1. Okay, so that means it's down. So let's go ahead and x and y coordinate axes. So I always go through the pole for these circles. My diameter is negative 2, meaning I'm going down 2. And how did I know it was down and not left? Well, because my center is at 0, negative 1. That means that my circle, well, such as it is down. So notice that this circle, remove this. This circle is down. So whenever we're dealing with sine, we're oriented on the y-axis, because remember, sine corresponds to the y-coordinate. So let's see what happens when we deal with cosine. So number 3, let's say we're given r is equal to 4 cosine of theta. Well, in this case, the diameter is 4. And since this is cosine, so let me actually underline diameter 4. I should have underlined the 2 up here. And the sine. So for us, since this is cosine, our center is now going to be oriented along the x-axis. So this is diameter over 2, 0, namely 2, 0. So this is to the right. The center is to the right. Okay, so x and y coordinate axes. X and y. 1, 2, 1, 2, 1, 2, 3, 4. My center is at 2, 0. My diameter, as measured from the pole, is 4. Okay, so my circle looks like it is a diameter of 4, a radius of 2. Wow, that was terrible. Why can't it draw a circle? There we go. Nope. Okay, there we are. So notice that this is to the right. It's oriented along the positive x-axis to the right. So I imagine if I had now a negative cosine, well, yeah, let's just do a negative cosine of theta. The diameter now is just a negative 1. And my center is going to be at negative 1 over 2, 0. Okay, so let's go ahead and plot this. X and y coordinate axes. Let's make this a bit larger in scale. So if my center is at negative 1/2, 0, and my diameter as measured from the pole is negative 1, my circle should have radius 1 and look something like so. And notice that this is oriented left. So whenever we're dealing with a cosine, it's oriented along the x-axis, much like cosine corresponds to the x-coordinate on the unit circle. So we're orienting along the x-axis, namely right and left. Okay, so I'm going to see you in the next video for 8.4.